Okay, we're live. So the last couple classes, we've been talking about disk method here on the left, where we're revolving around a horizontal disk by creating a bunch of two-dimensional outer disks and inner disks that we can cut from each other. Today we're going to be doing the same thing here on the right side with a vertical line. The setup's going to be slightly different. You can see what we're really doing here is we're building a bunch of cylindrical shells. So sort of like toilet paper rolls almost, where we're spinning a cylinder around the axis of rotation. In order to do that, we would need to have a radius, so our distance from this line that we're spinning to the axis of rotation, a height of that line, and then an infinitely small width. Once we've got all of that, then we can create a volume for the shell that we are spinning around. That volume would be 2 pi r, which is the circumference and that distance around the circle of that cross section, times h times w. Okay, so I'm going to show you again without the motion, I think. Okay, so the way to start is I'm going to create an infinitely small cross section here. So this is an infinitely small dx for our width. And then our height is our difference between our y values. In green is our radius, our distance to the axis of rotation. So I'll mark all that. This is our radius. We've got our height. That's blocked off from here to here, difference in our two y values. And our dx is our width, distance from here to here. Okay, I'm going to use that to spin this rectangle about our axis of rotation. So in 3D it would end up looking like this. 2, 3. Okay, we've got our infinitely small width that I'm drawing here in purple. The radius is still there in green, and here in red. Is our 2D block that we've spun around that vertical line in order to create our 3D cylinder. So we end up with this hollow cylinder. Again, the shape is like a toilet paper roll. Okay, so as for the volume, if I was going to cut this roll, so let's say somewhere like here, and unfurl it into a box, then our box would end up looking like this. With our infinitely small dx on top. The height of the box being the difference between those two y values, so it's still the height of the cylinder. And then the width of this box is going to be based on my radius. Okay, again, not the best coloring job, but we've got a height an infinitely small dx. And the interesting part, our width is actually our distance all the way around the circle here, which in 2D would be, if this is a circle, 2 pi r, the circumference. It's a little bit smaller so I can write. Okay, so putting all of that together, we'll get our general form for volume. Our volume is equal to this. Volume is equal to our width, which is 2 pi r. That 2 pi is a constant, so I'm going to pull it outside the integral. Our radius, though, is not. 2 pi r times our height. Times our depth, which is an infinitely small dx. Okay, from a starting x value to an ending x value. So from A to B. Okay, so going through this example. We've got the height of our cylinder, which is the difference between our two y values. Or my top function, which is the parabola, is x squared plus 1, minus my bottom function, has a y value of negative 1. So that's x squared plus 1 minus 1, gives us our height. So our height is x squared. Okay, our width is dx. I'm just going to do it in this color, I think. And then our radius here in green is my distance to the axis of rotation. Now that radius is always going to be your rightmost x value minus your leftmost x value. In our case, we have our axis of rotation here in black at x equals 4. And then our box has some x value as well here, which is going to change as we create those cylinders from the left to the right. It'll change between values of 0 and 2. So my distance between those, distance between wherever our x value is and the axis of rotation here is what we want. So if the whole distance is 4, and the distance up to our box is x, then this distance should be 4 minus x for our radius. Okay, if we plug all of that in, two pi times our radius to get our circumference, so that's 2 pi times 4 minus x, times our height is our difference between the two y values is x squared, times dx. Okay, and then we can integrate. So this would be 2 pi times the integral from 0 to 2 of, if I distribute that x squared, this will be 4x squared minus x cubed in terms of x. If we integrate, that would be 2 pi times 4x cubed over 3 minus x to the 4th over 4 from 0 to 2. Plug in our upper bound, subtract our lower bound, and we'll get our answer. Okay, so we've got 32 thirds minus 16 fourths. So I'll get a common denominator of 12. This will be 4 by 2 by 16. The 2 and the 16 is 32, times the 4 to get my common denominator. Minus, I'm going to multiply by 3 to get our common denominator of 12 on this side. Gives us 8 times 16 minus 3 times 16 is 5 times 16. The minus 16 and 12 can cancel as well. Gives us 2 times 20 over 3 is 40 pi thirds. Okay, again, not so concerned about the integration as I am about the setup. Any questions on the method? So for what we're doing for the setup. Okay, so let's try a couple. I'm going to help us out with the setup on the first one, or at least walk people through as we call. And then on the second and third one, I'm going to do completely you guys, I think. So first on my list is Aileen. So Aileen, I'm going to look for the height first. The height is the distance between the two functions. Okay, so for us, for this problem, I'm going to pick a point anywhere in here that you want and create our box. What is our height? Okay, I've got a chat coming through, 1 second. Okay, you're right. So our height is our difference in our y values, which would be negative x squared plus 6 minus x plus 4, which you've simplified in the chat to negative x squared minus x plus 2. Okay, that's perfect. I'm going to jump over to Jenna. Jenna, I've got the hard part. I need to be able to figure out what our radius is, which is our distance from the x value that we are at right now to the axis of rotation. Now that distance is going to change as our x changes from -1 to 1. So that does mean we need a variable in our equation here. The radius is my... write this in words. Is it x plus 3? Yes. Okay, radius is the difference in the x values in the same way that the height is the difference in the y values. The radius is always right x minus left x, and the height is always top y minus bottom y. Okay, so as Jana said earlier, our radius then, my red box right now is at x, so our radius is at x is my rightmost value here, minus my leftmost value here is -3, so that's x minus -3, or x plus 3. I dropped a line last time, so let me drop a line too. Radius equals x plus 3. Okay, and that does work even if this box changes to the leftmost side, or to the right side instead. So if I do, then I would take our x value, which is our distance from here to here, and add 3. So it should be more than 3, which makes sense. If my box is over here on the left side instead, then I would take my x value, which is now a negative value, so less than 0, and subtract a -3. When I do, I'll have an x, which is a negative value, plus 3, which will end up being less than 3 units, which is what we want. If this whole distance from the black line to 0 is 3, then our distance from the black line to the red line should be less than 3. Okay, last part is my width, which is always going to be dx as long as you're using shell method to revolve around a vertical line. So that will look like this. Here's our cylindrical shell that we just spun around the axis with an infinitely small width. Okay, and I'm going to try to not shade the whole bottom part this time so that you can still see the radii and stuff on the inside, but so get the sense that this is a 3D shape, but it's based off spinning a 2D shape about a vertical line. Okay, so now I just need to set this up. My general form is our volume is equal to 2 pi r is my circumference. That's my distance here in purple around the top of this cylindrical shell, times h, the height of the shell, times w, which is always dx, from a start point to an end point. Next in the order is Kelly. Kelly, what's my A and what's my B? Okay, and I'm going to copy over our radius, height, and width. So this is negative x squared minus x plus 2 times x plus 3 times dx. Okay, Kelly again. What's going to happen when I multiply these out? So before we integrate. Okay, you're right. So this is, I'm going to write it all out though, I think. So this is going to be a minus x squared and a plus 2x. What should come next?
Minus 3x squared minus 3x plus 6.
Okay, give myself a little bit more space here. Times dx. Okay, then I'm going to go through and combine like terms. I know you were kind of doing that earlier, so... And then I'll pass this off to the next person. So let's combine the like terms and we're done.
Okay. So negative x cubed minus 4x squared minus x plus 6dx.
Okay, so I'm going to pass this off to... next is Sarah. Sarah, what will happen if we integrate? Okay, that's cubed. Okay, and we're going from negative 1 to 1. So then I just need to plug in my upper bound and subtract my lower bound. Okay, for the upper bound, I've got negative 1/4 minus 4/3 minus 1/2 plus 6. Okay, then I'll go to subtract the lower bound. These different parentheses are still just parentheses. I'm just using the different types of parentheses to show you, to make it easier to see. I have to multiply that 2 pi times everything on the inside, but okay, so when I plug in that negative 1 to all of the even powers, nothing will change for the sign, but the odd powers will change sign. So this will still be negative 1/4, but the next one will be plus 4/3. So sign changed for all of my odd powers, 1, 3. Did not change for my even powers, 4, 2. Okay, so I've got negative 1/4 plus 1/4 will cancel. Negative 4/3 minus 4/3 is negative 8/3. Negative 1/2 minus negative 1/2 is negative 1/2 plus 1/2 will cancel. 6 minus negative 6 is 12. So we'll get our common denominator and multiply by 2 pi. Or 56 pi thirds. Okay, any questions on what we did here? Alright. So let's grab another. Next up is Kenichi. Kenichi, are you there? Okay, I want to know what the... It's a little bit laggy. Okay. I want to know what the height will be between these two functions. So what should my height be? Two. So my height will be 2 only at the point 4. But since we're going to move this rectangle all the way from the left to the right, and it's going to get bigger as we go. I do need a variable in my equation somewhere. Your height is always the difference in your y values. That's difference in x values from the start to the end. So my difference in the y values here be square root x minus 0, which is the square root of x. Okay, then I'm going to start looking at x values for my radius. Forget what color we used last time, so I'm going to steal orange. My radius is my distance from the axis of rotation to wherever we are right now. So in this case, to our x value. So for us, this is from x equals 0 to x equals x. Or x minus 0, which is x. And we've got an infinitely small change in x. Okay, I am missed a technique actually, so didn't actually get an answer there, I don't think. Although this is going to be a little rough to type. Okay, I'm going to go to Eileen and then come back to you because this is difficult to type. So, Eileen, how can I set up our volume equation then? Okay, 2 pi integral from 1 to 4.
Root x times dx.
Okay, root x times dx. Okay, I have just lost Kenichi, so I'm going to try to get him back in really quick. Okay, so next I've got Jenna. Jenna, how can I write this x root x so that we can use power rule? Okay, sorry. X to what power? Okay, this is x to the first power times x to the 1/2 power. Okay. What happens when I multiply these together?
X to the 3 over 2 power.
3 over 2 power. Perfect. So when we go to integrate, what will happen?
2 over 5x to the power of 5 over 2.
Okay, so what we just did there was we added 1 to the power to get 5/2. Then we divided by the new power. If I divide by 5 over 2, though, I'll be this multiplying by 2 over 5. And then we've got our bounds from 1 to 4. Okay, jumping over to Kelly. Kelly, what will happen if I plug in my upper bound right now?
It's 2 pi multiplying. Oh. 2/5 multiple 1 to the power of 5/2.
So I'm going to plug in my upper bound first, actually. This will be...
To the power of 5/2.
Okay, and then we'll do the same thing and subtract the lower bound to the other side.
2 pi multiplied by 2 whole 5.
Oops, sorry, 2/5.
And multiplied by 1 to the power of 5/2.
Okay, so if I needed to know 4 to the 5 halves power, what would you do first?
Is there a square root of 4 to the 5th power?
Yep, so what's the square root of 4? 2. And what's 2 to the 5th power?
32.
32. So I've got 2 pi times 2 is 4 pi fifths times 32 minus 2 pi times 2 is 4 pi fifths times... Okay, what's the square root of 1? 1 raised to the 5th power? 1. Okay, so I've got 32 times something minus 1 times something should give me what?
31
31 times
times something.
something. What is 31 times 4?
124.
Okay, so our final answer is 124 pi fifths. Awesome. Any questions on anything we did here? Okay, that was Kelly, so last one. Starting with Sarah. Sarah, what will the height of our rectangle be? Okay, x squared plus 1 minus 1, or x squared. Okay, then I've got, okay, Kenichi has dropped, so that brings us back to Aileen again. Aileen, what's my radius?
X.
Okay, our radius in this case is just x. And then our width is always dx. Okay, so if I spin this around, it will look like this. Okay, that's our infinitely small width, which forms our circumference after we spin it around. We've got our radius is my distance here in yellow. And after we spin our our height around, we'll end up with something like this. Okay, over to Jenna. What's our equation for the volume?
2 pi times the integral from 0 to 2 x squared times x times dx.
Okay, that's our HW. If we multiply this out, what will we be left with?
X cubed.
X cubed, okay? So let's go ahead and integrate.
X to the 4th power over 4.
Okay, then we've got the 2 pi on the outside that's going to stay. From 0 to 2. I think I'm just going to have you finish off because we're almost done. So what happens when I plug in the 2?
2 pi times 2 to the 4th power over 4.
Okay. What's 2 to the 4th power?
16.
16 divided by 4.
4.
And then times 2 pi.
So 8 pi.
8 pi for our volume. Awesome. Any questions on anything we did here? All right, you guys were great. I'm going to go ahead and post this to the WeChat. And we should have the video up at some point tonight. We're going to have 10 more questions, sort of like we did for the other CUDA problems on disk method and washer method. That'll be due for this class by Thursday. We'll have a mixed review for our next class. And then we've actually got a short week this week. So when we come back next week, I'm going to have a mini quiz on the disk and shell method for the next week. And hopefully, if all goes according to plan, we'll be able to possibly even take that in class instead of having to do that here. All right, thank you guys very much for coming. If you guys have questions, please hit me up on WeChat. We'll be doing more practice, mixed practice with disk and shell method next time. I'll catch you later. Goodbye.
Bye.